Hello. In this video, we're going to see how we can fit the eye direction for every frame of an HMC sequence. Let's start with loading a neutral face mesh. I'm going to drag and drop the model here. Now let's load the mesh sequence from the guidable replace step. Let me also load a neutral texture. So, here we have our animated mesh sequence. Then, let's load a generic eyeball base mesh from our gallery. I'm going to use the flat eyeball version. Let's drag and drop the model into the graph editor. You can use any custom eyeball mesh, just make sure that the eyeball is located at the world's origin. The world's origin is going to be the center of rotation for the eyeball. Also, make sure that the eyeball looks towards the Z-axis. Now we can use the previous created transforms to place the eyeballs inside the eye sockets of the actor. To do that, I'm going to create a load transform node. Let's load the transformation for the left eye. Let me also load the left eye texture that we created in the previous step. I'm going to assign this texture to the eyeball using a set texture node. Okay, now let's do the same for the right eye. Let me copy these three nodes. I'm going to paste them using Ctrl-Shift-V. Let me change the file paths for the right eye nodes by changing left to right. With this done, we have our neutral face with properly set up eyeballs. Now we need to find the rotations of the eyeballs to perfectly match those on the HMC camera image. To do that, let's load the image sequence from the top camera. First, we need to match any image from the top camera with our 3D geometry. Let's start with loading the calibrated camera. I'm going to create a load camera node. Let's choose a corresponding JSON file for the top camera. Now that we have the camera, we need to undistort it using an undistort camera node. We also need to undistort our image sequence using an undistort image node. In the 2D viewport, we can see how the current frame looks before and after the undistortion. Now we need to transform the face mesh so that its position matches what we see on the camera image. Our original sequence is located in the stabilized space. First, we need to remove the effect of the head stabilization. I'm going to create a load transform node. As the source of the transformation, I'm going to load the sequence of transforms from the guidable head stabilization step. Let's turn on this option to invert the transformation. Let me also call this node destabilization. Here you can see the result before and after the destabilization. Now, let's transform the model from the destabilized space to the camera space. To do that, let me create another load transform node. I'm going to load the transformation file that we created during the head to HMC alignment step. Here we have the face properly located in front of the camera. Let's rename the last node to Transform to HMC. All we need to do is to repeat this step for the eyeball geometries. Let me duplicate these nodes and connect them to the left and right eyeballs. Now we can use a Fit Eye Direction node. The first input is the left eye geometry. The second input is the right eye geometry. The next input is the undistorted camera model. Then we need to plug in our undistorted camera image. The last input of the node is going to be the facial detection that we created during the lip and eyelid detection step. Let me create a load facial detection node. I'm going to load the result of the facial detection step as a sequence. Facial detection provides information on where the eyelid contours are located on the image. I'm going to plug it into the last input of the Fit Eyes Direction node. Now let's switch to the visual editor and click Compute. The node computes rotations of the eyes that match the render of the eyeballs, pixel to pixel, to the corresponding camera image. As you can see, the computed rotation pretty accurately matches the real eye rotations. Let's go ahead and test another frame. The node works reasonably well when the eyes are half closed. But when the eyes are almost completely closed, it's not going to give a good result. I will show you how to deal with these situations in the next tutorial. For now, let's see how we can save the results of the gaze computations. First, I'm going to transform the eyeballs back to the world's origin. The fast way to do that is to use a Copy Transform node. The first input is going to be the eye transformation before the direction fitting. The next input is the result of the direction fitting. If we turn on the Invert Source Transform option, it will bring the eyeball back to the world's origin while keeping its computed local rotation. Now let's create a Save Transform node. I'm going to create a folder and call it Fitting Eye Directions. Inside, I'm going to create a subfolder called Left Eye Transforms. As for the file name, I'm going to use frame4hashes.json. Now let's duplicate these two nodes for the right eye. Alright, if we go to the Nodes menu, click Compute All, and process the entire sequence in batch mode, we'll see a result like this. That's it for this tutorial. See you in the next video.